In order to divide polynomials with long division, we need to first review dividing numbers with long division. Now, this is probably not something you've seen in a while, so let's review it. Right, we're looking at 2,923 divided by 6. Now, we translate this into long division. That's going to put the 6 on the outside. 2923 is going to go on the inside right there. Now, what we're looking at is how many times does 6 go into 2? It doesn't, because 6 is larger than 2. So now let's think again. How many times does this number 6 go into 29? Right, we're kind of parsing out our division here. We're not looking at 2923 as a whole. We're just looking at the number 29 right now. Right, and 29 divided by 6 goes in evenly, the number of 4 times. So next up is multiplication. 6 times 4 is equal to 24. Remember, we are taking this 4, multiplying it by 6 to get 24. Next up is, after that multiplication, is subtraction. Right, we're only looking at 29 over here, minus 24. We're not looking at the whole 2923. Remember, this is the process of long division. 29 minus 24 is equal to 5. And the next up is to bring down this 2. Now we're going to start this same process, this same thinking process all over again. That's 52 divided by 6. 6 goes into 52. It's going to be 8 times. 8 times 6 is equal to 48. So that goes down here. We are subtracting. 52 minus 48 is equal to 4. And the very last number that we have, 3, comes down. And we're going to look at 43 going into 6 7 times. Sorry about that. That is my pencil acting up. 7 times 6 is equal to 42. And our remainder is 1. So our answer here is equal to 487 with a remainder of 1. Also known as, written as a fraction, 487 plus 1 over 6. All right, so what we're doing here is putting the remainder over the divisor. And our answer here is the quotient. So let's apply this to long division of polynomials. We have a polynomial here, which is 2x squared minus 5x minus 1 divided by x minus 3. So in the same fashion, remember that 6 went outside. X minus 3 is going to go outside now. And our dividend, 2x squared minus 5x minus 1, is what's going to go inside. Now remember, when we back here when we did this number, we only looked at 6 going into 2, and then 6 going into 29 because 2 was too small. And we're going to do the same thing over here, a very similar thing. We're not going to look at x minus 3 going into the whole polynomial, 2x squared minus 5x minus 1. We are only going to look at 2x squared and x, right? The first 2 terms of each. This goes in 2x times, right? 2x squared divided by x is equal to 2x. And this 2x is what's going to be the first part of our quotient. Now the next step up here was to multiply. We multiplied 4 times 6. So now we're going to multiply 2x times x minus, sorry about that, tried it again, didn't work, 2x times x minus 3. And that's going to become 2x squared minus 6x. So now what we're doing is we're taking 2x squared minus 5x, and we are subtracting 2x squared minus 6x, right? Notice that back when we did this step by step, I focused on, we were only subtracting 29 minus 24 over here, right? This extra bit of 23 didn't really matter in the beginning of the first stage. And that's the same kind of thing over here. This negative 1 doesn't matter right now. All right, that's going to come into play later. But for right now, we are subtracting these two polynomials, 2x squared minus 5x minus 2x squared minus 6x. So here's what I like to do when we are encountering a problem like this. I'm going to use green here. Because we're subtracting, this minus sign is going to distribute. So over here, in the body of this problem here, you could do it off to the side if you want to, but we can change this to a plus, flip the sign of the 2x squared to be negative, flip the sign of that negative 6x to be now positive. And we are subtracting. Right, 2x squared minus 2x squared is equal to 0. Right, this has to cancel out. Next up, negative 5x plus 6x, that's equal to x. And just like long division, that leftover piece comes down, x minus 1, and we're going to start this process. We're going to start this three-step calculation process over again, this time beginning with x over x. Right, that is x from here divided by x from here. And this is equal to 1, so a plus 1 goes on our quotient. Multiplying next, we have 1 times x minus 3. So that's going to become x minus 3. Excuse me. Next up is a subtraction. X minus 1 minus x minus 3, right? And again, what I like to do here is to change this to a plus, change that and that, right? Flip the sign of everything inside the parentheses after changing this minus to a plus. This is because the addition is easier than subtraction. So now our x's cancel out here, and negative 1 plus 3 is equal to 2. So our final answer is a quotient of 2x plus 1 plus our remainder 2 divided by our divisor, x minus 3. Right, so this is our full answer for number 2. All right, number 1. Number 2 here is going to be similar. So let's write it out. It's a little bit longer, which means it's going to be a longer solution, but it's really just more of the same when we're doing the division. It's more of that same three-step process, right? First up is to divide 50x to the third divided by 5x. Once again, the first term in our dividend divided by the first term in our divisor. And this is going to equal 10x squared. Next up is to take this 10x squared, multiply it times our divisor, and that's going to be 50x to the third minus 40x squared. So we're subtracting these. All right, and I'll do it right over here, which is changing this to a plus, changing that negative 50, changing that 50x to the third to a negative, and 40x squared was a negative, now becomes positive. So let's do our subtraction now. 50x squared cubed minus 50x cubed is 0. 10x squared plus 40x squared equal to 50x squared. Let's bring down our negative 35x. So once again, the first term, 50x squared divided by 5x is equal to 10x to the second power. And this is positive, so that means there's a plus sign right in there. Now that we are multiplying this 10x squared times 5x minus 4, that's going to become 50x to the second power minus 40x. Oh, I messed up. That should be a 10x, right? this is equal to 10x. So let's subtract. Changing everything, minus to a plus, positive to negative, negative to positive, inside the parentheses. 50x squared minus 50x squared cancels. Negative 35 plus 40 is equal to 5x. That's right over here that we did that computation. Negative 7 comes down, just like that. And we start this process all over again. This is the last time because there is nothing left to bring down. Looking a little bit to the future. So 5x divided by 5x is equal to a positive 1. Right? That's, once again, 5x here divided by 5x there. So 5x minus 4 is the result of 1 times 5x minus 4. We're subtracting these two polynomials. That's a plus, that's a minus, that's also a plus. 5x minus 5x is equal to 0. Negative 7 plus 4 is equal to negative 3. So our final answer is a quotient of 10x squared plus 10x plus 1 plus a remainder of negative 3 over 5x minus 4. Box it in because that is our answer. All right, let's do one more problem. Negative 4x squared minus 5 plus x to the third divided by x plus 3. So x plus 3 is our divisor. And watch how I write down the dividend over here. Right? Notice how it begins with a negative 4x squared, but this here is x to the third. We have to rearrange these so that they're in order. And we have to rearrange these so that they're in descending order. That's by descending order of degree. So x to the third goes first, minus 4x squared. And one more thing here is that our exponents are counting down from 3 to, there is no x to the first, but then there is a constant of negative 5 over here. So what we must do here is put in x to the first, right? These are placeholders. Because x to the first is missing, that means it does have to be represented in some way, and we're going to do that with a coefficient of 0, right? We're not really changing things, but we are kind of putting x to the first in as a placeholder. So now that we have our dividend in order, we can begin. X to the third divided by x is equal to x squared. So let's put that above the x squared slot. And now let's multiply. X squared times x plus 3. That's going to be x to the third power plus 3x squared. So now we can flip everything. We can put this down. We can flip this to a plus, this to a minus, and let's circle that and put a minus down so that we know that that is now a negative 3x squared, negative 4x squared, plus negative 3x squared, right over here, is equal to negative 7x squared. And let's bring down this plus 0x, right? Again, that's the placeholder there. So now negative 7x squared, the first term, divided by x, the first term, is equal to negative 7x. So this here, we'll put a negative 7x, and then we'll multiply this negative 7x times x plus 3 to get negative 7x squared plus minus 21x. Thinking ahead a little bit here. Let's do that subtraction. All right, and by doing this subtraction, we're going to flip the sign of everything. All right, all those minuses now turn into pluses, and now we are adding. Let's see, these cancel, this cancels. 0 plus 21x is equal to 21x. Negative 5 comes down, right? So now negative no, sorry, not negative, positive 21x divided by x is equal to a plus 21. Right, once again, that's from here, 21x divided by x. And we did that computation off to the side over here. So it's a good idea to keep some space on the side to do your calculations. Hopefully it won't mess up your actual working space too much. And if you need to use a separate piece of paper, go right ahead. That's not a big deal. So now we can distribute 21 times x plus 3 is going to become 21x plus 63. Subtraction once again. Sorry, gotta do that. And let's change all these signs here, right? Minus becomes plus, positive, negative. Positive 21x becomes negative, and this positive 63 becomes now a negative 63. So the 21x minus 21x cancels out. Negative 5 plus negative 63 is negative 68. This is our remainder. So our answer here, x squared minus 7x plus 21 plus a negative 68 over x plus 3. All right, so thank you for watching. Hope this was helpful.